This is Jacob Owen, Aruba Systems Engineer, starting up my video walkthrough series of configuring Aruba products. Today we're going to talk about the configuring of Aruba CX switches in ClearPass to support the use of downloadable user roles. Downloadable user roles are a great way to centralize policy enforcement. So what actually happens is you define the roles on ClearPass, and then whenever a user authenticates and needs that role based on the ClearPass policy, the switch will actually log in to ClearPass and download the most updated copy of that. This allows you to scale to 1,000, 10,000 switches without having to touch 1,000 or 10,000 different switches if you need to add an access list or add a a bandwidth throttle or a VLAN change. This can be done in a single location, and then as the clients re-authenticate, they will get a new copy of that downloadable user role. So it definitely is great as in large environments, but it can also be used in small environments. I have a gigantic environment. So we are going to F switch here that is completely unconfigured. And we're going to actually walk through the process to configure this so that it can communicate with ClearPass, authenticate, do .1x MAC authentication, as well as download those user roles. The other component of this is that I have a ClearPass cluster. It's a 2-node ClearPass cluster that is pretty much mostly unconfigured. The only things that I've done on it are obviously I put an IP addressing, certificates, but most of the rest of the configuration is going to have to be done during this setup. So as part of this, we're going to start with the switch config. That's probably the easiest of the two. So we're going to go through here and we are going to log in. So the first time you log into a CX switch, the default username is admin and the password is blank. As soon as you do this, it's going to pop up and request a new password. We're just going to set it as admin, make it easy. Okay. Now you can see this text file on the right. That is the information I'm going to pull from for this switch so that I can kind of keep myself on track. We're going to set a host name. Set some of our default information like DNS, NTP, just the basics of the switch that we need to have working before we can actually, move into the more complex config. So we're going to do IP DNS, server address, 8.8.8.8, and then 4.4, and then NTP server. We're just going to use pool ntp.org. And then we're going to enable that. Okay, so we got DNS, NTP set up. The next thing we're going to do is we're going to set up the VLANs. So for each of these VLANs, what we'll do is we will give them a name, and then we will set some default values that I use for each of my VLANs. Things like client track IP address, IP IGMP snooping, and DHCP v4 snooping. V11 is name is secure. Paste that. So for voice, VLAN 12 is going to be a little different because we have to add the voice identifier so that IP phones know what is the voice VLAN that they should be pulling their information or IP address from. 13 is guest. 14 is AP management for APs. And then VLAN 15 is Okay, so that's pretty much all the VLAN setup information we need. The last two things we need to do is we need to enable DHCP for snooping globally, which is what this command is going to do. As part of this, you could also set an authorized server. So if you had a specific IP address of a DHCP server, you could actually put this in addition to putting the uplink. So the uplink is a required component of DHCP v4 snooping, but the server authorized servers are not. So you have to have an uplink port defined so that when it receives DHCP requests or responses from the DHCP server, they will be allowed through. You don't have to set up an authorized server. If you want to do that for additional security, you can, but in a lot of large environments, like a lot of my customers, they have so many authorized servers that they don't want to determine which ones to use at which sites. So they just say, let all the servers come through, but only use these uplinks. Okay, and then the last step we'll do here in a little bit is we will set up the trunk, I'm sorry, the uplink trust on that. So we'll do that here in a minute. Next thing we're going to do is we're going to set up our radius. So one of the things that kind of drives me crazy is that we don't have the ability to expand the terminal width. So meaning as I type this out, you're going to see that it starts to kind of right back on itself and start from the left. Oh, shoot. So you can see there that it's actually starting back from the left now. This kind of makes it very difficult to read, especially as you have a large amount of information still to put in this command. So one of the things I'll always do is I'll just copy and paste this out of a Word document that I can kind of control what it looks like. But for this, I'll just put in at least one of the two radius servers the old-fashioned way. The next thing we're going to put in is the ClearPass username. So this is actually a username that's defined on the ClearPass server that allows the switch to log in and download those roles. So this is actually specifically done on the ClearPass box, but we have to reference it on the CX switch. So in this case, it's just AOSSDOR because I started with AOS switching when I created this. And then the ClearPass username or password is context. So that's the first one is done. We'll just copy and paste the second one in there. Okay, so the second one is now in there. We're gonna do the show run. And we can see that, oh, I made a mistake. I have too many ClearPass boxes in my environment. Okay, so now we should have both the ClearPass servers defined as the radius servers, demo-NAC1 and demo-NAC2, as well as all the ciphertext for all the radius keys and the ClearPass password. The next thing we're going to do is we're going to create the server group. So this is where we're actually going to reference those two servers in a single group for 802.1x and Mac authentication. So one of the things I like is you can do a show running config current context, and wherever you're at in the config hierarchy, it'll show you just the config for that section. So in this case, I was in the server group Radius ClearPass, and it showed me just the configs that were part of that. So that's what I wanted to see. The last part of this is that we are going to do what we call dynamic authorization. So that's another term for that is COA, or change of authorization. So what that is that allows the ClearPass box to actually send a request to the switch to bounce a client, or to terminate a session, or to do something once a certain action occurs. Why that's important is things like wired guest. If you're doing wired guest, you actually have to have something kick the client off the network to bring them back through the authentication process now that the user is logged in. That'll be part of a different video that I do later. So what we actually have to do okay, we're not in the context. So there is no context for the dynamic authorization like there is with the server group. That's why it wouldn't show up there. But what you can see here is we've put in Radius Dyne authorization client, the two Radius or ClearPass servers, and then their ciphertext, or their key, if you will. So pretty much from a Radius perspective, we're just about done. The only last thing we need to do now is we need to set up .1x and MacAuth to use ClearPass, that Radius server group ClearPass, when a user comes on and they need to either do MacAuth or .1x. So we're going to do authentication, port access, .1x authenticator, and it is Radius server group, and here's where we actually call it out. And we enable that. So what that's saying is when a .1x client comes online and needs to authenticate, we're going to use the Radius server group ClearPass to do it. And then we're going to do the same thing for Mac authentication. Okay, and with that, we now have MacAuth and .1x both using ClearPass for the authentication. The next step we're going to do is we're actually going to modify the uplink so that we can get network connectivity outside of this device. You can check real quick to make sure, but I believe we're on 1125. Yep. So we're going to go into 1125. I always like to set my MTUs to 9198 across my environment. There's no downside to doing that. And then we're going to do a VLAN trunk native. 10 is my management, so it's the untagged VLAN. And then I'm going to allow all VLANs to come across that trunk. The last thing we're going to do is make sure to do a DHCP v4 snooping trust. So what this is allows the DHCP responses from the server to come through this interface. If they were learned on any other interface, they would be blocked. Then the other thing we need to do now is we need to go into the management VLAN and set up our IP address. And then we have to set up our default route. And then we need to go into interface VLAN 1 and do a no IP DHCP, because we don't want DHCP running on VLAN 1 because it's no longer needed. That is the default, but we're not using that. Okay, so now that we've got this working, we'll verify that we've got, yep, and you can now see that I'm getting MAC addresses coming across 1125 on 10, 11, 12, 13, 14, and 15. So that is expected. And then we can verify that we can ping our upstream gateway, which we can. Okay. The next step we're going to do is we are going to set up what we call a local user role. What this is a role that would be used if ClearPass was not available. I kind of think of this as a fallback VLAN that gets clients online in the event ClearPass was down or was not responding, if you will, or the switch was cut off. So what we have to do first is we have to create a class. And you'll see whenever we do the ClearPass section later, when we create the downloadable user roles in ClearPass, it follows this exact same format. This is what you would call a local user role. So this is if you were not using downloadable, you could reference the local user roles instead of using downloadable, but obviously you're going to have to create each of those local user roles on every switch in your environment, and any changes that need to be made would have to be done on each switch. Another advantage of downloadable user roles. So we're going to create and allow any role. We're just going to say match any, because we just want to get users working while ClearPass is down. We don't want to have them having to take a long coffee break or bagel break to go while the network's being fixed. Next, we set up port access policy. I'm going to call this CPM down. And then we're going to match the class we just created above. And the thing to note here is we do have the option, if we wanted to do an action, but if we do not call out an action, the default action is permit. So in this case, we're just going to get rid of this, and we're just going to say match everything and allow it. And then the final piece is that we are going to create the actual local user role. We're going to call this one ClearPass down role. And we're going to associate the policy we just created above. We're going to set the auth mode. So the auth mode is how the switch authenticates each client. So there's client mode, and then there's also device mode. So client mode will authenticate every single user that comes through a port that is that has .1x or Mac authenticated. If you set this to device mode, it will only authenticate the first user that comes through, and then the rest will be allowed through. A perfect example of this is an access point. So you want the access point to be authenticated, but you don't want the users that are coming through that access point to be authenticated as well, because they've already been authenticated by the access point. There's no need for a double authentication. So depending on what your device type is, we either use device or client. In this case, we're just going to assume that most devices are going to be standalone PCs, things like that, that need to have individual authentication occur. Okay, and then we set a VLAN. In this case, we're just going to set a trunk of VLAN trunk of native of 13, and then so what this does is we set the native VLAN or the untagged on this role to VLAN 13, which is guest, and then we are letting all the other VLANs also come through from a tag perspective. Obviously, if this was a true production environment, I would most likely drop users onto the guest VLAN, but also restrict access to what they can get to. But in this case, we're just wanting to get the users on the network and have them function. Okay, so now we've got our local user role defined. The last piece that we have to do, well, there's two more pieces that we have to do, and that is we have to set up the individual interfaces to do 802.1x and Mac auth. So what we're going to do is we're just going to do a range command with the interface 111 through 1124, and then we are going to pretty much set up MTU of 9198, VLAN access of 1. So in this case, we're just dropping them onto VLAN 1, which has no connectivity, but ClearPass is going to override whatever this is set to. Then we're going to set up port authentication. We're going to set up a client limit of 32 for .1x. Once you like that, port access, client limit, okay, 32, okay. Then we're going to do, this is where we're going to set up our port access critical role. So this is if ClearPass is down, this is what the switch will use at a per port level, and it's going to refer back to that ClearPass down I hate the terminal width setting that you can't modify that. Port access critical role. ClearPass down. Oh, roll. Yeah, that's what it was. Okay, and then we will then set up 802.1x with the .1x authenticator command. We will set the EAPOL timeout to 3. We will set the max EAPOL request to 2, and we will enable it. These values are all adjustable. You know, in certain environments, maybe where you have heavy MAC auth and no .1x, you might shorten some of these timers just to get the devices on faster. We also have the ability to fire both MAC auth and .1x at the same time, with obviously .1x being preferred. But if you have a heavy 802.1x environment, you might want this extra time to make sure that the clients can respond and get online. The next thing we'll do is set up our MAC-based port access MAC off. We'll enable that. Okay. So if we look at now port 1111, just as a snapshot, you can see we've got the MTU set, we've got the VLAN access set, we've got our client limit set to 32, our critical role has been defined as ClearPass down role, we've got our .1x set up with its timeouts, and then we've got port access MAC auth set up and enabled. The last piece that we have to do on the switch, because we're just about done at this point, is we actually have to go through and set up, for downloadable user roles, we have to create what we call a TA profile. So what the TA profile is it is the signing CA certificate that signs the ClearPass cert. And what that does is it tells the switch to trust the certificate that ClearPass is going to exchange, because whenever they do a downloadable user role, it is an HTTPS exchange. So therefore, the switch has to trust the certificate that ClearPass is presenting. And the way we do that is that we tell the switch to trust the signing CA that signed the ClearPass cert. So in order to find that, we actually have to go into the switch, into ClearPass. And there's a lot of people don't know this, but there's actually a way to pull this directly without having to go into the certificate. If you go to http:// the name of the server .well-known/aruba/clearpass /https-root.pem, it will actually create this, or it will show you what the root CA certificate is that signed the ClearPass cert. So from here, all we then do is we just go to crypto PKI TA profile, and I'm just going to call this AAA certificate. And then I'm going to do a PKI TA profile certificate import terminal. So there's a couple different ways you can get this certificate brought into a switch. One is TFTP, SFTP. My preferred way is to just copy and paste it from this file on the right into the switch. And we do that with the TA certificate import terminal command. It's going to say paste the certificate in the PIM format below, and then hit enter and Control D. So I'm just going to paste this in here. And then I'm going to do Control D. And now you can see after I hit Control D, it's asking me, are you sure you want to import this with the following attributes? And you can see that this all matches exactly the signing CA that I use for ClearPass. And it just makes sure that I want to accept this, and I do. Okay. So with that, the switch is pretty much configured and ready to uh, start doing downloadable user roles against ClearPass. So now with that, we will jump into the ClearPass side of things. As I mentioned before, this is pretty much a unconfigured ClearPass cluster with just a few things that I've done just to get basic connectivity working. And you can see there's 2 nodes here. I'm going to expand this out a little bit, make it easier to see. Okay, so we're going to do this a kind of a little bit differently. What we're going to do is we're going to make sure all the pieces that we're going to have to reference in the service are done before we start the service process, because I'm notorious for going through the service process creation first and not having the things available to reference, and then I have to either save it with a bogus value or cancel out entirely and go back and do this. So I'm going to start this the correct way from the get-go, and that is primarily going to be enforcement profiles, which are the downloadable user roles, roles, which are where we actually do the role mappings to determine within the ClearPass service, and then the authentication setup, so the server. So in this case, if we think about the way we do a service creation within ClearPass, it goes authentication, authorization, role mapping, and enforcement. So we're going to kind of build that in a reverse order and go first to our authentication sources. And we don't have any, so I'm going to create one, and it's going to be called OwenLab AD. It is going to be a Active Directory. I'm not going to worry about any of this other information because we don't have any other. This is a small lab, so we don't have backup servers or anything like that. Plus, there are also some better workarounds to doing redundancy from an AD perspective without the use of backup servers. So in this case, I'm just going to put in my IP address, my AD server. I don't have any connection security. I'm just going to put in my base DN is going to be okay, and then I'm going to save this primary base DN. Okay, didn't like that. DC Owen Lab -dc.net. Okay. Oh yeah. Okay, we'll save this. We'll come back in here. So essentially what it was asking for where do you start the lookup within the for this Active Directory server. So sometimes you might have users at a different level, and you might need to go down to a lower level or bring it up to a higher level to make sure that they're inclusive of the users that you're wanting to hit. So now if we do a search-based DN, you can now see that, I've got devices showing up, so that's exactly what you want. We're going to save this. So now we've created our OwenLab AD authentication source. Next thing we're going to do is we're going to create our profiles. So this is whenever we kind of get, this is my favorite part of the process, because we can actually essentially build the downloadable user roles and then reference them. So what we're going to do here is we're going to call this, so we're going to create a CX wired AP role. So this is going to be referencing the access point variables. And so what we do here is we look for the CPPM role. So this right here, this is where it's essentially returning a downloadable user role. If you use number 1, like it had by default, that would just be returning a Aruba user role for local user role that's already been defined on the switch. So in this case, we're going to go in here, we're going to create this. And what I do here is I usually just will copy and paste into here, just because it makes it so much easier. You can build this offline, you can validate it works on a switch, and then you can copy and paste it in here. The other thing I like about this is that it gives me the ability to do comments so that I can help understand what each of these things are doing. So like this one, it matches all IP traffic. This one matches DNS, matches DHCP, and then under the port access policies, it tells me what this line does. It allows the AP to perform DNS requests, allow the AP to obtain a DHCP, etc. And then down here, this is just where we call out this specific information and associate the policy and set up VLANs. And as you can see here, we've done the auth mode, device mode. So that's where only the first device is going to be authenticated. Okay. There is another option. We could do this if we wanted to do oh shoot, I completely spaced that. Okay, normally you're supposed to do Aruba downloadable role enforcement. I just went in with an Aruba enforcement, but I changed it within the service, so that should still work. The other option you have, instead of copying and pasting it in here, is you can use this advanced wizard or standard wizard. I'm personally not a fan of it because it's a little too hard to follow. I mean, all the stuff is pretty much, you have to call out anything that has not already been built. So if you're trying to reference a class or you're trying to reference a policy that hasn't been built, you'll have to do it in here before you can do it. Whereas with the copy and paste method, you've already created it, or you're creating it in the role, so you don't have to actually, do anything other than just do it one time. So we're going to go back to CX. We're going to do it as advanced. There you go. And as you can see, there's that Aruba CPPM role. Same thing as I did on the other one. I just didn't call it a downloadable user role. In this case, we're going to call this a corporate PC role. So this is where my 802.1x users are going to get. And you can pretty much see the same thing. They're allowed pretty much access to everything. The only thing I've done here is I have put a CIR. So I've kind of tried to do a committed information rate for these clients so that they don't, overload the internet link. But this can be done on an individual role basis, which is like I did here. CX Corp PC role. And I could put a description in there if I want to know what this is, but I try to make the name descriptive enough that I know what it's being used for. Save. Okay. We'll do this for a couple. CX. IP phone. Roll. Oh. CX advanced. So phones are a little bit weird because you have to figure out what type of tagging that the phone expects. So in this case, it's assuming I'm just dropping them into the Access VLAN 12, but there are some where you have to actually tag it to the voice VLAN that's being defined on the switch. Yep, save. Okay. Now we're going to do 2 more. Actually, 1 more. CX mobility switch advanced. CX wired IP camera. So I wanted to bring a camera in here because I wanted to kind of show the capabilities of the of role-based access and how we use that, for security purposes. So what I've done here is I've created an IP camera downloadable user role. It matches pretty much traffic. In this case, it matches traffic from anything on this VLAN or anything that's assigned to this role to these locations. So I'm saying you can match on ICMP to this host and match on this to this host, as well as DNS, DHCP, but I'm blocking everything else internally. So you can see here I've done a block to everything else internal, and based on the order of this, I'm going to be able to get to these two links even though they are part of this internal networks, but because of their order, they're going to be allowed to go through first. So I can do pings, and I can go out on TCP port 5000 to get to this IP address of this server, whereas everything else that's going to be on or destined for an internal network is going to be dropped because of this action drop right here. And then of course we set up our camera role and associate the policy, and that's that. Okay, so now we've pretty much created our roles, and this process could be repeated 5 times, 10 times, 100 times for however many types of devices you have out there. Because what we're going to then leverage is we're going to leverage the profiling capability of ClearPass to determine what type of enforcement should we do based on the type of device that's connecting. So the next thing we're going to do is we're going to create our roles. So these are just little tags that we add inside of the system that we then reference in the role mapping policy. So when a device comes through, we say if it's been identified as an IP phone, then give it an IP phone role. If it's been identified as an IP camera, then give it an IP camera role. This will make a bit more sense whenever we see it. IP phone, core PC. Okay, so now that we've created the roles, then whenever we create the role mapping policy, we'll have these roles that we can reference. Okay, the last piece we want to do is we want to make sure that these servers are connected. Okay, they are not. So what we'll have to do here is we'll have to join the ClearPass servers to the AD domain, and the reason we do that is because when you're using eat peep, it is a required function to join it to the domain for security purposes. If you don't do this, you will get failures whenever users try to 802.1x authenticate. This is not required for EAP TLS, but in my case, I'm kind of lazy, didn't want to set up certificates, so we're just going to do eat peep, make it easy. Shoot, I can't ever remember my, hang on one second. Sorry, I'm just looking up my okay, there it is. Okay. So it's owen-lab-dc-1.owenlab.net. So you have to put in the fully qualified domain name of your Active Directory server. It just has to be one, and then it'll obviously go out, reach out, and join it. And then down here, we'll just put in the administrator account that has access to actually join or create a computer or machine account inside of AD. Because I'm using external DNS, it does not it cannot do an AD lookup to determine the net BIOS information. So what I'll have to do is change this real quick. Just going to restart the services. This is something I normally set up when I'm setting up the original ClearPass config, but I wanted to make sure I called this out, so I left it purposefully in there as 8.8.8.8 so that I could get that failure. Okay, just waiting. Okay, obviously once this is done, we'll be able to redo that AD join. It'll be able to do a lookup against the domain controllers in that domain. Okay, so I'm still waiting for it to, I probably shouldn't have closed that. Okay, so yeah, it's coming in now as the into the subscriber because the services are offline for the publisher, so therefore the VIP service has floated over to the secondary. Should be back up here in a few. Normally it doesn't take this long to restart the services. Okay, I think what's happening now is it's trying to get the secondary, or it's the VIP's trying to float back over. So let me just close the screen. And I'll just go into Act 1. Yeah, so if I navigate directly to the ClearPass node, I can get in, but it going to the VIP that's shared between the two of them, I wasn't able to. So, okay. And then on the side screen, I'm actually restarting the services on number 2, so we don't have to wait on that again. So while that's happening, we're going to go back over here to Server Manager, go back to Server Configuration, join the AD domain, and you can see now that 10.1.10.254 is set up as a primary. this again. This thing's all kinds of. Okay. Sorry about the delay. I guess whenever you restart, even if you start the services on the second one, it seems to really impact the first one as well. So, all right, let's go into this one. We'll join the AD domain. Okay, and you can now see that it's reached out, queried DNS, and it pulls the NetBIOS name. We are adding the host to the domain. Okay, and you can now see that this server has been added as a to the owen-lab.net domain. So we'll just go back here. We'll do the same thing on AD. This is a per server requirement. So even if you had 8 nodes, you'd have to do this on all 8 of them. And if you had multiple domains, you'd have to do the same. Okay, so now that portion is done. So now let's get back to what we were originally working on. So now what we're going to do is we're going to create the actual services. So this is where, we're going to take those profiles and the role mappings and things like that, and we're going to put them together so that we can actually take action on them and send back the downloadable user roles to the switch. Okay, well, I'm gonna do. We're not doing ETLS. We'll just leave those there. OwenLab AD. Okay, so for 802.1x, we don't really set up any role mappings just because we don't really care about what the device type is connecting. I mean, we could, if we needed to, look at the device type that's connecting and then make some type of action. But in this case, we're not going to, so I'm just going to bypass that. And then what we're going to do here is we're going to add a new enforcement. And the default profile is just going to be deny access. Okay. So in this case, all we're going to do is we're going to say, something pretty basic. Like the tips role. So if the tips role equals user authenticated, so what that means is that means a user. So essentially, tips is a is an internal tag. That's what we reference. If we were to create role mappings and we were to map the roles to something inside the service, it would be a tips role that we would then reference in the enforcement. So in this case, use anything in brackets is default, meaning any user that comes in and is successfully authenticated against Active Directory is going to be given a user authenticated tips role. So what we can do is we can match on that and then just say, hey, as long as the device is authenticated, then we can let them through, and we're going to return back a CX corporate PC. Now we could go so far as to say, if the user is authenticated and they're part of a certain division of the company, we could give them a different role, like accounting or IT or management or something that we would leverage AD against to look at the user, what AD groups they're part of, and then make that enforcement. But in this case, we're just going to do it as, is the user authenticated? Yes. And then we just make sure to choose that after you make the enforcement, because otherwise it won't save. Okay. 802.1x is pretty easy, obviously, to set up. Obviously on the PC and AD side is much more difficult, but in ClearPass it's pretty easy. So now we're going to get to the kind of the fun one, and that is Mac authentication. Okay, so in this case we are going to do authorization, and we're going to profile endpoints. So what this is going to do is, these are when the radius attributes come in from the switch or device, it's going to check against these, and if they all match, then it's going to fire this service. So in this case, we're just going to do Ethernet because we don't really care about wireless right now. And then if the service type is login user or call check, it's going to match that as well. But you can see here it matches all of the following conditions. So pretty much all three of these have to apply. For authentication, you have two options. One is you can do allow all Mac auth or just Mac auth. And the reason why the differences is that if you use Mac auth, that means the client has to already be in ClearPass, and it has to be a known endpoint, meaning it has to have already passed through some mechanism to then change it from an unknown device to a known device. But because we're probably going to be doing wired guest on the same network, we would need to do an allow all Mac auth, because we don't know who's going to be connected to the network, so we're going to let everybody in, but then we're going to use the profiler and things like that to determine what access they're going to get. But the wired guest portion of this is going to be beyond the scope of this. It's in the next video I'm going to be doing. The authentication source is going to be the endpoint repository, because that's where we're going to pull information from. So for additional authorization sources, so if we call out something in the enforcement, we have to make sure that it is set up as an additional authorization source within the service. So if we were wanting to say, users can only connect between 7 a.m. and 5 p.m., and we were to put that in our enforcement policy, you could only reference the time if the time source was set as an authorization source. Because right now, the only thing that ever gets automatically added as an authorization source is whatever the authentication source is. So in this case, it's only the endpoint repository. So if you did not put the time source in there and tried to reference time, it wouldn't work. Now for roles, what we're going to do here is we're going to create a new role mapping policy, and it's going to say okay, so the default role, I'm going to call this other. So that means if you don't match anything, you're going to get other whenever it passes over to the enforcement policy. So the first thing we're going to do is we're going to create one that just pretty much looks at the endpoint repository. It is going to say category equals, in this case it's just going to be, oh, we got a camera in here. Network camera, there we go. So when a device gets profiled, it's going to come through with a category and other values that we can then match on when the device connects. So in this case, it's a network camera, so we're going to give it an IP camera as the role name. We're going to do the same thing with IP phones. No, not, yeah. Category equals VoIP phone. Oh, last one. And then if the endpoint repository, if the category equals access point, we're going to give the access point role name. The other thing we're going to do here is, and actually I forgot to add this, but this is one of my favorite things that I'll kind of come back to this. So right now these are our three mapping rules for roles. So we'll just make sure we've clicked this, and now you can see IP camera, IP phone, access point. The reason I also like to use role mappings is whenever you're using Access Tracker, these role information will come into the summary tab, so you can very easily figure out what role is it getting, and therefore why is it hitting the enforcement policy that it is, or the condition that it is. Without that, it makes it a little tougher. All right, so in this case, we're going to add a new enforcement. And the default action, normally the default action would be a deny. What this will most likely end up looking like after the next video is it will be the guest captive portal. So that means if you come through and I don't know what you are, you're going to get the guest captive portal, because otherwise you would hit one of the other services based on the type of device you are. But in this case, we'll just put it in as the deny access because I don't have a captive portal for guest yet. And then we're going to add a rule. So in this case, this is where we talk about the tips role. So we just created those tips roles in the role mappings. So we're going to say if tips role equals access point, then we are going to respond back with a wired AP role. And we're going to mark the endpoint as known. We're going to do the same thing. We're going to do the same thing now for tips role equals IP camera, and we're going to do endpoint known. Wired IP camera. And then we can also just do a copy rule here, make it easy. Find this last one. And change this from IP camera to IP phone. We just need to make sure to call that out. So the profile, that's actually something else that I want to bring up. So when you're, this normally applies in Mac auth scenarios, but there's other times that it might. But what the profiler does is if a device authenticates against ClearPass via Mac auth faster than it can profile, so profiling takes maybe 1.5 seconds to 2 seconds depending on the latency between the in the load on the ClearPass boxes. Sometimes what will happen is the client will actually outrun the profile. So what happens is the device comes through, it doesn't have any information about the client, and we don't know what to do with it. So what we do here is we set up this profiler, and what this does is that in the event that any information about that client changes after it's authenticated, it will take action based on whatever this radius COA action is. So in this case, we're dealing with wired switching on CX, so it's going to be AOS CX bounce switch port. A lot of people ask me, well, what happens if a device comes through that you don't know what it is, but it needs to be able to get out to DHCP because that's our primary profiling method? Well, the way we do that, and I forgot to do this earlier, is we set up something called a profiler role mapping, and a service or an enforcement. So what this is going to look like is we're going to go through here. Already is download. CX wired profiler enforcement. And it's going to be CX switch. It's going to be advanced. And so what we're going to do here is going to be very, very simple. I'm just going to steal one of these from one of the other ones I've already created, which is another reason why I love to use copy and paste. So what I'm doing here is I'm essentially creating a policy that only allows a DHCP to occur. So what it's essentially doing is we're going to apply a downloadable user role to the client to give them VLAN, or put them in a VLAN and give them DHCP access. That's our primary method to do profiling. Once the profiling is actually done, it's going to then force that client back offline and bring them back in to re-authenticate. And now you'll have, you'll know what the device is before it tries to connect. That's part of our zero trust strategy or story, if you will. Sorry, I just need to profiler policy. Okay, we're going to put this in VLAN 13, which is actually going to be our guest VLAN, because they don't need access to anything. They just need to be able to get DHCP. Okay, so we class IP DHCP. We're going to allow DHCP to work, and that's it. Everything else is denied because there's a denial at the bottom of this policy. And then we set up the port access role, profiler role. Description is the same. Associate the policy that we just called out here. Client inactivity timeout. We can just leave that whatever. And it is going to be a client mode because we want every user that gets this to be authenticated, or to try to authenticate. Okay, we're going to save that. And now we're going to go back into our services. We're going to go to MacAuth. We're going to go to enforcement. And what I'm going to do here is I'm going to say, if the category equals unknown. So what this means is that I'm not able to have or get enough information about the client, or if the category is blank, does not exist. Where are you at? There it is, right there. Not exists. Then we're going to give this a profiler role. Where did my profiler role go? Oh, there it is, profile. Okay, so what this means is that if something comes through and I don't know what it is because I haven't profiled it yet, or the category does not exist, I'm going to give it a profile role. The other thing is that if something comes through and doesn't match one of those conditions, it's going to get the other. So what I can do here is I can set it up so that I can say, add rule, if tips role equals profile, then I'm going to give it a profiler enforcement. And I'm going to do the same thing, copy rule. Do the same thing for if tips role equals other. So in both both situations, it's going to return that profiler enforcement. And with that, we now have pretty much the services created that we need. So now what we're going to do is we're going to start plugging stuff in and see what issues we may or may not have. Just plugged in a phone. they're coming up. There's one piece that I forgot. I knew I was forgetting something. So this is actually a good troubleshooting thing. So obviously, these devices are sending the switch is sending radius information to ClearPass. ClearPass is not showing anything in the access tracker, nothing at all. Even if it was hitting ClearPass and it was not being seeing a service, that would actually show up here. So what that tells me is that I have forgotten to put this in as a network access device. So I haven't added this device to ClearPass so that it can terminate the radius session and accept requests from it. Where I find this at I say that and it should be in here. Interesting. Go into the switch, make sure. I may not have. Wait. Maybe I didn't plug it into the right device. Okay. Yeah, I see my issue. I forgot that 6200F is no PoE. So I'm trying to think now, how am I going to test this? Well, what we can do while I think about how to get this working is I can see if... So what I just did was I just plugged in 2 more connections to that switch, but they are not PoE, they are PCs. So I should be able to see them hitting ClearPass. Okay, so I've got full connectivity to ClearPass. Not sure what's going on here. Okay, there we go. That's what I've been waiting to see. So what you can see here is that um, this radius authentication attempt from an unknown NAD. This is what you would look for if you realize that um, the server does not have has not been defined. I'm sorry, the switch or AP has not been defined inside of ClearPass as a NAD. This will not show up in Access Tracker, so that catches a lot of people. So I always say look at Access Tracker if you don't see anything at all regarding that network access device or switch or AP. Look in the event viewer under Access Tracker down here, because what that'll most likely do is show you where you might have forgot to add it. So what we're going to do is we're going to go in here. We're going to add the switch as a NAD. And we're going to call this 6200F lab. And now we're just going to put in the same information here as we put in on the other. We're not going to worry about TACAC's shared secret right now. This vendor name also gets a lot of people. This needs to be the type of device that it is, and why that is because it's part of how ClearPass determines what type of COA action to send back to the device. If you have like a Cisco device in here, you know, if I put this in here and I change it from Aruba over to Cisco, it's going to try to send a Cisco COA to that device, not an Aruba COA, and it won't be understood because they use different VSAs. The other thing to remember is Aruba CX switches, as well as Aruba access points and gateways, the vendor name for that is Aruba. Whereas if you're using AOS switching, so like the older Pro Curve or 2930s, 5400s, things like that, that would be Hewlett Packard Enterprise. So that always gets a lot of people as well because they think that it's they're all Aruba, but they're not. They're actually different. They use different VSAs, so just something to be aware of. So now we'll add this in here. Oh, the radius secret. I guess I can't type. Oh my gosh, am I really that bad at typing? Okay, there we go. So now that device is now in there. And what we're going to do now is I'm going to bounce those two ports via the switch. Okay. Okay, so we've got a reject. Hey, at least that's working. So I think what's happening here is that there is a trust issue between the client and the ClearPass server. Good gosh. Yeah, I'm definitely getting an authentication failure, but it's only because of the certificate. That's what this is telling me, is that an unknown CA. So even though I've pushed out the certificate to the clients via Active Directory, for some reason they're still not trusting it. So I will have to work on that and figure out. Probably just do a group policy change. For some reason, it's probably trying to use EAP-TLS, although these are all showing up as EAP. Alright, well, what we can do in the meantime is I will set up wired MAC auth enforcement roles. So what I'm going to do here is I'm going to set up a mapping rule just to get these online, just so that we can see what we're doing, especially if I need to do a group policy update. I'm going to say if the endpoints repository category equals and then under the enforcement, what we'll do is we will do enforcement rules add if tips role equals corporate PC, then we're just going to drop them into the corporate PC role and mark the update as known and point as known. Okay, so now we should have, all right, just to make this easier, I'm going to shut off So what I'm going to do here is I'm just going to disable 802.1x on those two ports so that we can just have them come up as MAC auth, so we can at least make sure that we're getting the information we need. Okay, so now you can see, like I said, I removed 802.1x from here, and now I'm just doing a pure MAC auth for these two devices. I see one of them has an IP address, but I don't agree with that. I see where it says VLAN 1 is untagged. My guess is we're having a problem with the role. And so what we'll do is we'll do a show port access clients interface 1/1/11 detail, and this will show you details about the client, how long they've been online, whether they're MAC auth or .1x, whether or not the if the role failed, which it did for some reason. Okay, so server authentication failure. Getting ahead of myself. So the reason why it failed was because I did not create the AOS dir user. So what it's doing is it's actually reaching out to the switch is reaching out to ClearPass like it's supposed to, and saying, hey, I need, that downloadable user role, and the ClearPass is saying, I don't know, I don't have, one like that. So what we're going to do is we're going to come in here, we're going to create one. It's going to be an admin user, AOS DUR, AOSS DUR, AOSS DUR. Okay, and then the privilege level can be just Aruba user download role. So what this does is that gives them this user just access to download roles. So now, okay, still seem to be having an issue now. The nice thing is once you get these first few worked out, it's very easy then to. I mean, once you make the change and it starts working, it'll work on all of them. I mean, that's another beauty of the centralized policy enforcement is once you fix it in one place, it's going to apply pretty much everywhere the same. Okay, so role parsing failed. So now we've got an issue with something in the role it didn't like. You can see right here, role parsing failed. So what I'll do is I'll do a show logging-r. Okay, so this really isn't going to tell us anything because it doesn't go into detail. So what we'll do is we'll do a debug, port access, role, and then what we'll do is we'll do a show debug, buffer, module, port access. So what this is showing me is this is showing me the debug information just for this specific process, if you will, the download process. And then we'll do a shut no shut again and see what changes here. There we go, right there. And as you can see, execute role error, class does not exist, internal networks. So it looks like maybe I got a little ahead of myself and created something that didn't already wasn't called out in the role. So let me go back in here. Okay, let's check this. Okay, so we have a class IP any, class IP DNS, class IP DHCP. So we're calling out, so as you can see right here, we're calling out an internal networks, but we don't have anything up here above it that actually creates that. So what we could do is we could either create it or we could just remove that line. Just to make it easy, I'm just going to create it. Internal networks. 10 match IP 10.0.0.0/8 20 match IP 172.16.0.0/12 30 match IP 192.168.0.0/24. Boom. Okay, so what this is now doing is I'm creating this network and then I am calling out this and I'm giving it pretty much full access. So let's see if that works now. This command right here is, oh man, what is going on with this? Okay, so role parsing failed again. Show debug, buffer, module, port access. Okay, so now we've got another issue. So essentially what's going on here is when I created this role, it needs to be any to these addresses, and I just put in the addresses. So it's missing the word any. So now let's see. Okay, so it looks like one more issue. I'm just going to get rid of this because I don't. So as you can see, all I did was I just walked through the downloadable user role and fixed the things that the debug showed me were wrong. Um, I'll go back and fix the CIR stuff. I don't know why it's failing that command. I've got it in other working solutions, so it's probably maybe a space or something that shouldn't be in there. Okay, now this is what I expect to see. So now you can see this is the client name. This is the user role. You can see it's CX Corp PC role -3002-4. So that's an identifier that ClearPass adds. So the 3002 is an identifier that ClearPass adds to make sure that there's no duplication of user role names. And then the -4 is like a version number. So every time you make a change, that'll change to -5, -6, -7, -8. That's how we do version control with downloadable user roles. So you can see now that these users are online, they're in VLAN 11, and they now have IP addresses showing up in the system. So they are working as expected. And from here you can now see they've been online for 53 seconds. Here's the IP address. The VLANs assigned are 11. They're pulling this from the downloadable user roles. They are MAC authenticated. This is the role that they're getting. This is the client mode, the inactivity timeout, all the stuff that we put in the downloadable user role. It's pulled out here. And then you can also go down here and see the individual access list policies that are tied to this user. So you can find out from here what they're allowed to do or what they're not allowed to do. So now if I were to have a PoE switch or find an injector somewhere around here, I could easily throw on an access point and walk through the same process. But like I said, if I brought on 100 more Windows PCs, turned off .1x, they would come on just like these, because obviously they would come in as they would be profiled as a computer. They would then come in as a computer. If it was an access point, once I fixed the roles, if there were any issues there, they would come in as an access point, and we would be able to see that information. But like I said, if I want to make a change to this, let's make a change to this policy, just so we have it, so we could show it. Still don't know why that's not working. Well, let's just set it up so that we just drop anything destined for the internet. Let's say you're not supposed to be going to the internet. So now if I bounce these users, you can now see that this 3002-4 right here has been changed to 3002-5. So you can see that's how we do version control. And now, obviously, if I had, like I said, if I wanted to make this change across 1,000 switches, I make it in one place, and then I just make sure to either hard bounce the users or wait for their re-authentication to occur, and now they have the new role downloaded. Yeah, thank you for bearing with me during some of my technical challenges. Like I said, this is the first time I've done this in about 5 years, so I'm still a little rusty, but hopefully going forward I'll have some more success. If you have any questions, obviously reach out via YouTube, or you can also reach out to me at certmaster@gmail.com. Um, or you can look me up on other social media platforms. So thank you very much.